الفقرة الأخيرة لحفلنا اليوم راح تكون مع متحدث متميز راح يعطي الكلمة الرئيسية اللي هو الدكتور صفوان وشاه. دكتور صفوان وشاه أستاذ مشارك في قسم علم الحاسوب بجامعة بيرمونت، وهلأ حاليا هو فول برايت سكولر بيقضي سنة بجامعة الأميرة سمية. الدكتور صفوان وشاه مهتم بالماشين ليرنينج والديب ليرنينج وتطبيقاتهم، بالإضافة إلى الجزء النظري منهم. تطبيقات بتشمل الكمبيوتر فيجن، اوبجكت جيو لوكيشن، داتا اناليتكس، ايمج بروسيسنج. قبل ما دكتور صفوان يبدأ مسيرته الأكاديمية اشتغل بشركة زيروكس وبالو آلتو ريسيرش سنتر. شاركوني الترحيب بدكتور صفوان وشاه المتحدث الرئيسي لحفلنا اليوم.
يعطيكم العافية جميعا، وأنا عارف إنكم تعبانين، وآخر يوم ويوم نص الأسبوع يعني يوم 3، بس إن شاء الله مش راح أطول عليكم، راح نعملها، هم حكوا لي نص ساعة بس راح نعملها 20 minutes إن شاء الله، لأني منكم فيكم. A keynote speaker is true, they always kind of sometimes they bring people from outside. This time I'm lucky to be with you, so basically I did my bachelor degree in BSUT, Princess Sumaya University, وماي ماستر ديجري بالجامعة الأم في الجامعة الأردنية. بعدين عملت سوني بافالو كمبيوتر ساينس PhD، وبعدين رحت كنت لاكي أشتغل في جامعة في شركة اسمها زيروكس، هي أول شركة بتعمل برينترز. وبعدين لأنه صار ال AI wave كبيرة I got lucky even and I moved to Palo Alto Research Center. This is kind of a very prestigious center. Then after that, I decided to switch to academia, like most of you guys here. Then after that, I decide once I get promoted, I decide to come back for a 1-year visiting here to Princess Sumaya University, back again. From where I start, I end. And I was lucky again to be with you all today. أنا بشكر دكاترتي درسوني. أنا شايف منهم دكتور عمر الأصفر، شكرا لك إنك درستنا وصلتنا لهون. دكاترتنا اللي من IEEE بخص لهم بالشكر. زملائي كثير بشوفهم هون. كان في ناس بيشتغلوا بالديبارتمنتس أيام ما كنت الدكتور عصام. وكلكم يعني صحيح أي واحد بده approach me please do. I'm not much more than you. I just get an opportunity from somewhere else. I'm try to share it with you. So what I do is I do machine learning, deep learning. I am AI guy. That's my definition. And I do it as applied and as a theory. So I intersect both in multiple domains, in transportation, in energy, in healthcare, and many other domains. العامل المشترك اللي ما بينهم كلهم هدول في عنا wave of science, wave of AI. And this AI wave has came, but has many issues, this wave. Before I jump, I know there is tons of technical issues today. It works finally. أنا لما اشتغلت في زيروكس رحت على research center called Palo Alto Research Center, and I got lucky to be there. إذا بتلاحظوا في نص السلايد في جهاز قديم هذا اسمه ألتو. أي واحد بيشتغل هناك بينزلوه على البيسمنت وبيعطوه درس عنه. هذا أول personal computer get invented. هذا الجهاز في كثير باتنتس، في كثير تكنولوجي. إذا بتلاحظوا في ماوس هناك، هاي أول ماوس get created. This is very kind of fun. I didn't participate of any of those inventions, but I want you to understand from where I spent 3-4 years in Palo Alto Research Center. They invent the object-oriented programming. They participated in inventing it, to be precise. They did the GUIs. Now any window you want to maximize, minimize, this has been created there. If you don't believe me, go to YouTube and Google or put in YouTube just Steve Jobs, and have in there also Xerox PARC and see what he's saying. He stole all of this stuff to Apple company at that time. Why is this? Xerox is a printing company. They invest in this as a research. Why they didn't take it any further? Who took the opportunity? Steve Jobs at that time. Okay, enough politics. Then I moved to University of Vermont, and I created my own lab. I have many PhD students and master students. I started with a little of them, then I increased, alhamdulillah, shway shway. Now I have 8 PhD students and 5 master students in my lab. I am growing, so if you see yourself that you can join, or you know someone who's brilliant and he wants to continue, I am open, so we have opportunities there. So, as you know, AI is everywhere. And the massive wave of this AI came from industry. That is because they are behind it, because there's value, because there's opportunity, there is a dollar sign after it. And it's applied in different fields. By the way, I am cheating here because I got some images from ChatGPT. I am an AI guy and I have the right to do such things. So, I just want to share with you my story. So I did many applications in machine learning, and also I did some theory. So the first application that I am proud of, just to show here, was geolocalization of objects from street images. You can think of it as an easy application. Professor, you can just see those images, you can see that sign, we know it. The task in here is to not just only recognize the sign, but also what I want to do, I want to put it on the map down there. That's the task. So, in autonomous vehicle, when they drive, they process frame by frame, and they talk their decision on a frame based. No further any processing is done after that. But for this one, because you have multiple objects that can show in different frames, frame 1, frame 2, frame 3, it's the same object. If I want to put them on the map, they will show as a multiple objects for the same object, right? So it's not going to work. So I have to do what we call the tracking system. So the system in general works like this. This is the system. The system starts by processing every single frame by frame, but we need to change things in there. And now this is the first problem of AI. Things does not apply from wherever you got it. So you need to change things. And that is what we call narrow AI, which means narrow AI that we have now does not scale to all applications. You have to take it and you have to tweak it, and that's actually very painful. So now what we do in here, we process every single image. Instead of just simply saying where is every single sign and it is a frame, we need to specify it is GPS location. And after that, because I said before, if you remember, that those signs appear in multiple frames, we need to combine them if they look similar. That's why we have similarity network, and we have a Hungarian algorithm at the end here just to have some probabilistic model to make sure that we have the right association between the objects, and then we build the track list and we spit it out on the map. I hope that technology will work now. We're going to show you some demo about this work. Hopefully you can absorb the idea behind it. We're going to open now a website. That is actually the story behind this project. It's actually started from a coffee shop. My department head was listening to 2 people from the transportation departments, and they want to process most of their images and most of their work at their end. Okay? And now they start talk, and I came to UVM and they engaged me, and this is what is actually a talk from a coffee shop ends up with. Most of the research in US, by the way, is just a chitty chat in the hallways and end up with the production. So take care of that all the time. You go and talk to others, chat with them. So hopefully you get something useful out of that. Can I get the mouse? Thank you. Okay, so this one, as you could see, this is Vermont. This is the state of Vermont. We own all the images from state of Vermont, and we process all those images and we localize all the signs in the state. And we do it every single year. So if you just go in here and we want to see an image, you can just click on this image and you can see it. If you want to see the sign, you can just see the sign and you can see. You can click it on it. What's the benefit of this project? What's the idea behind it? Why we are doing such things? You can basically save all the assets of the road assets. You can understand signs. You can understand intersections, lane marks, you can guardrails, sidewalks. You can put all of those assets on the map and you can keep tracking them for maintenance, for safety, for different reasons. For autonomous vehicles also can be useful, for precise mapping as well. The second application that I would like to share with you is some people work in power systems here. Anyone work in power systems? Anyone? I can skip it if no one. But anyways, this is actually kind of a machine learning for forced isolation. Forced isolation can be risky. The blackout that happened in Jordan 2 years ago, I guess, we have a blackout, right? You remember, was forced isolation. And forced isolation, the problem with it, you need to mitigate the source and you need to disconnect it. So what do? I go and talk to the people in power systems. I put my shoe in their feet and I do the machine learning, hopefully to get a better results. And that's what we did. So I got a PhD student from BSUT. He did his master there in power systems and we did system together. This system is working really well. We get great results. And in milliseconds, you can, if you detect a forced oscillation, you can mitigate it in milliseconds. And you can actually save a lot of assets in power system grid. And now, because AI is fun, and I always put this slide. And this slide, it says there are some faces they are fake, and some faces they are real faces. So the fake faces, they are generated by AI. Which one do you think is fake? Which one do you think is generated by AI? Actually, all of them, they are fake. All of those images, faces, they are fake. Just to let you know that the generative models, generative AI, is very, very powerful. Actually, ChatGPT, anyone knows what the GPT stands for? G stands for generative pre-training models, which means they came from the same concept in here. They use transformers because they call G for generative pre-trained transformers, okay? And they use actually kind of GANs and diffusion models and autoencoders just to generate such amazing look faces. So what I did, at that time, I got a call from a professor that I know, a Chinese professor in Purdue, and they said, Safwan, I have an idea. Now, you know antibiotics, the bacteria can't resist those antibiotics, right? And that's actually a very huge problem in the medical field. Because it's a huge problem, we need an alternative. What's the alternative? Alternative is something that Allah Azza wa Jal is put it in our body, what's called peptides. Those peptides, they are natural resistance, natural defense for those bacterial, fungal, viruses, name it. But the problem, they are very few. They are maybe around 5,000 known in the world. But the question is, can we generate similar ones that can fight similar look viruses from the same family using the same peptides? That's the main question. And the idea is to use these generative models. So the generative models in general is to look at the distribution, learn it, and try to sample from it. They're similar to the faces. You get a lot of faces, you train on faces. Another question, how I can sample from my training set and new faces that never existed but look like faces. The same thing in here. That's what we did in 2020. And we did research for 2 years, and we persist in this research until we get a good results that we've been taken to the lab and tested in there. And from 6 experiments that we conducted, 2 of them, they showed really active results. We went to NIH, we get $2 million to conduct this research over 4 years. That's very amazing. You can see the AI. But the problem is, again, I'm back to the problem. What's the problem? I need to specify my models to this problem. So I need to do a lot of hard work. I don't have any sort of models that can scale in a good way. So, and this is actually another example, I don't want to mention it, but you can see the power of generative models. You see these 2 images in the middle here? This is a very poor landmarks, and that's the good quality landmarks that you can use generative models to generate the same image with the high quality landmarks. without any pixel by pixel labeling. It just you put a good and bad and you just run your model. That is very beautiful thing to do in this world now. Now, but this all what we mentioned, again to the limitations, to the narrow AI that we've been talking about, if you remember. So the narrow AI is you cannot do the same model that you trained, okay, and you take it to a similar task even, but it's slightly different, you need to start again. That's the problem. One example, you as a human, you drive a car, and I get you to a golf field and a golf cart and told you, drive this car. You will have fun, you will drive it right away, right? The problem with AI, if you train a system, a self-driven car in a city, and you just focus on the city, and you take it to the golf field, it's gonna fail miserably. You take everything, the system, the sensors, exactly copy-paste into the golf field, but on the golf car, it's not gonna work. Why? Because it's this narrow AI, okay? So, what to do next? Now, just to give you a very quick example about this problem. In my lab, what I do as a theory side, I do a lot of applications. I have half of my lab, we do applications. This one is the theory. The theory, what I'm trying to answer in my career, I'm trying to understand a certain geospatial area from different sensory information, from ground images, from aerial, from satellite. All of those to understand a certain spatial area. One of those problems that is actually very, very challenging problem in the field, which we called it image geolocalization. If I give you an image in Amman city and told you where this image has been captured, tell me the GPS information for that image from the visual information only. You know these days what we have a problem with the GPS, right? You remember that? So even GPS, the error for GPS, you know that it is plus minus 5 meters, right? So even if you want to have self-driving cars in Jordan, they will crash right away. They have many reasons to crash, but this one of them is GPS, right? So, and by the way, for fun, the autonomous vehicles, they have problem with the flying bags. The plastic bags. كياس البلاستيك اللي بتطير. Actually, this is a very major problem in US, but they have no plastic bags. Actually, in the states that I live in, there's no plastic bags in the market. They forbidden those. So they have no problem with that. But if you came here to Jordan, you will have flying bags everywhere, right? So it's not gonna work from that perspective, at least. But the question that we try to answer here is how, if I give an image, okay, just from the image itself, can you tell me where's the GPS information? That's a very challenging problem. My lab is trying to address this problem. And we try to, and we actually, just to let you know, we are the state of the art answering this question from my lab, which means we are, out of 15 groups, we are doing the best, we are actually getting the highest results so far. But even though, it's a very challenging. And the way how it's done is very easy. What we do, and not me, everyone, we do it in a cross view, which means I have a ground image in the top here. I'm trying to compare it with the satellite images, because satellites is kind of fixed view, and if I can map between the ground and the satellite, I can tell the location. The problem is, the view of the ground is a little bit different than the satellite, so you need to imagine this kind of mapping. AI is good in that, if it's trained well. If you trained well, it's good in that. So, my lab, what they did, we get this system, okay? I'm just trying to make a point here. I'm not going to discuss this kind of models with you. You see this, the down image there? You see the accuracy for the same area where we trained the system, let's just say on Amman city. And this, you see the cross area here. Imagine that we tested on Mafraq or Irbid or Salt or whatever. The accuracy there is 96 trained on the same area. The same system, just take it to a different city. It is a struggle, 60-something%. That's the top results. The AI system these days struggles with this kind of scalability on unseen data. It's a problem. But it's a good problem so far, by the way. So that's why we need a third wave of AI. We've been living, so far, people can define it 4 or 3 waves, but we can tell you it's a 3 waves. The 3 waves that we need the 3rd wave in AI that will have system that scale. I'll tell you, from the culture perspective, the 3rd wave all the time, it is the massive wave. زي ما بنحكي هون بالأردن الثالثة ثابتة. If you go to Chinese, they will say the same. They have the same concept. If this AI wave reach, it will be massive. It will have a good things and will have bad things. And that is what I'm trying to deliver this message to you. The 3rd wave of AI is going to be destructive if we are not taking the precautions from now. How? Let me tell you something. First of all, the first wave of AI started in back 2010 and before. And I'm just going to give you an example so you can understand. People, if you have a chess game, the chess game that you want to train an AI system to solve it. So the people before 2010, what they did, they said, I will come up with a smart rules and smart states that I will give it to a small machine learning algorithm and will learn from there. So they have what we call it, at that time, the reasoning. You have a reason behind your decision. These days, from 2010 until now, what they do, they said, I don't care about the reason, I don't care about things, just give me training data, I will learn from the data, I don't care, I just give you high results. That's what the current system do. They learn, actually what they do, just to summarize it in here, they have 2 players, they do chess. The first one, the second one. The one they lose, they will say it's not good, bad. That's the bad training sample. The one that win, it's a good one. So they create this kind of clashes between 2 players and they learn by, this kind of loop. But at the end of the day, they don't really care how you win. You might actually have a chess playing and at the middle you take an action and this action has nothing, doesn't make any sense. Why? Because it's trained from blind data. Now we need a 3rd wave that make reasoning and make learning, both together. If this comes, then we are really in a bad shape. Why? First of all, the ChatGPT, just to give you, I'm just trying to make the presentation very quick here. ChatGPT, when it's generated its output, the ChatGPT itself doesn't understand it. It just learn it and just give it to you because it will make you happy. That's it. They train people, they just sit there and every single sample, this is the way they just generate, and if they are happy about it, they just say happy. If not, they just move on. What is my worrying me about AI wave, the 3rd wave, that when it comes, that are we ready for it? Because imagine, we're gonna have, I'm not worried about the technical, because we're going to have a lot of good technicalities there. We're going to solve a lot of problems. But imagine that your kid is sitting in a room having an avatar AI, chatting with them. And when they chat with them, they will build a relationship. They will build a friendship. They will build a social. And those social, they might be constructive. You might control them. But the problem, those trained on data from outside cultures dominated by different big countries that are different than ours, right? So basically, at the end of the day, you will see yourself actually being occupied by AI. And now I'm not saying here that AI will beat a human. I'm not saying that. This is a big debate. What I'm saying, we're gonna have an AI wave. We're gonna have an AI wave that have a reasoning. And if this happens, it will scale, which means your kids will go to school, they will have an AI that's going to teach them in the 1st grade. The same AI will teach them in the 2nd grade. The same AI will teach them in the 3rd grade. And now you're going to start having this conversation with the AI, and they become socially and become more updated, and so on, so on, so on, so until we reach to a point saying we need to abandon that. But because we need to take advantage of the AI, we need to be aware at the beginning, right? We as a scientist, we as engineers, sitting on the cutting edge technology, we should understand its limitations, capabilities, problems, and we should be aware of that from now. Just at least to be aware. That is what I'm going to say for tonight. Thank you very much, everyone. I'm happy to talk to anyone after that. Thank you. I was trying to hide. Okay.
السلام عليكم.
عليكم السلام.
شكرا دكتور وشاح على البرزنتيشن.
Absolutely.
Dr. Khalil from the Hashemite University. I just have a question about the geotagging. I liked the first project that you worked on, so which is a geotagging, right, of the signs through the roads. So while you're training your narrow AI, are you changing or you're converting the perspective images to satellite images, for example, and match those? So like it's a top down. So does that help? I know it's like the signs, they are vertical, but is there maybe other benefits maybe that you would...
Actually, I'm not doing satellite, but that's a good point. I will tell you a secret here. It's very useful. Why is that? Because the perspective, all the areas around it, will be useful to map that sign from ground to satellite.
Exactly.
It will give you a clue.
Yeah.
No one did it. This is a patent. Don't tell anyone.
Thank you.
Yeah, sure. Questions? Yes, Dr. Ala?
Thank you very much. My question is, if we look at a human being, he can understand images, understand sounds, and he can understand multiple things. My question to you, can we have an AI model that do multiple understanding? Like, for example, he can do multiple things. From my understanding that normally you make a model trained for specific tasks. Can you make one model for multitasks, like the human, for example?
Yes, absolutely, you can do that. But the problem is, if you change just a little bit of this sensory information. So let me answer this question by this way. We are humans. We mimic things. We create things. Right? At some point, we have the reasoning. We can create the idea. The problem with the AI now cannot do that. For example, someone born blind or even get blind. All these sensory information that came in from the visual will be, the auditory system will occupy them. The other sensory information will occupy the brain and take over those and train and use those cells and neurons to have a better perception. On the other hand, if you have a system that's trained in auditory information and for some reason the microphone is dead for years, you are not going to get anything. It's not going to work. But it's if you train it on multiple system, multi-sensors data, yeah, it's going to work, definitely, yeah. Other questions? Okay, thank you very much. دكتور مصر حياك الله.